Oh, I have a wonderful thought experiment for you, CC.
Okay.
So this is from Twitter. I am. I will link it in a second because I want you to. Actually, maybe you can follow along with me.
You are delayed for me, so I can't actually follow along with what you
No, no,
show me.
but I posted the link. You can open it maybe.
Uh, I think so. Yes.
Okay, so I thought I had all the consciousness thought experiments, but TSHL Neuro AI Librinsky Lab told me a new one that literally kept me up last night. It's Camilo's idea, but I've taken liberties. So it's Camilo Libidinsky. Um, Answer the polls in order that you read them. Assume we are able to precisely record the intracellular voltage from every neuron in your brain for 30 seconds. Let's say during those 30 seconds you are looking at yourself in a mirror and waving. Now we're going to voltage clamp every single neuron to exactly reproduce the recorded voltage with the exact same time course for 30 seconds. Question 1. Do you see yourself waving in the mirror during that voltage clamping? Doesn't have to be the exact same experience, but do you experience something pretty similar?
Yeah, I would think so.
So still waving, you're not seeing anything, or you're not sure.
Still waving.
Okay,
I don't know. But,
that's good. Okay, so now we're going to do the same 30-second voltage clamping again, but block the ability of one of your neurons to communicate with one of its postsynaptic neighbors. We'll put up some kind of barrier to prevent all neurotransmitter from traveling in that one synapse. It won't affect any spiking because we're carefully voltage clamping every neuron. So yeah, so every neuron's still doing the exact same voltage clamp thing. Second poll. Do you still see yourself waving in a mirror?
but that shouldn't. You're forcing everyone to do the same thing again, right?
Exactly.
I think I should still see myself waving.
All right. Okay. All right. Now let's do that neurotransmitter blocking for all synapses in the brain. We clamp again. Do you still see yourself waving in the mirror now?
Oh, all synapses.
Remember, all neurons are firing exactly the same action potentials. They're voltage clamped precisely. Do you still see yourself pretty much, normally waving?
But I'm not sure now. I don't know how much influence the. No, but the activity in each neuron is still exactly the same.
Yes.
I think I should see myself waving. Uh oh. I'm not sure. But if we don't have sign, but the voltage clamp is all powerful, right?
Yes.
Yes, the voltage clamp. If my brain does the same, it should. Yes. Okay. I'm still seeing myself waving
Okay. Okay.
because otherwise I wouldn't have seen myself waving in the first. Because I'm worried about other things, neuromodulators and stuff. But I
Mm-hmm.
don't think it will. It will change the experience maybe a bit, but I don't think it will stop me from seeing myself waving. Okay, we go on.
All right. So all this voltage clamping is getting tiring, or don't I know it? Let's distribute that work across neuroscience labs around the globe. We are going to ship your neurons to different labs. So each experimenter will get precise instructions on how to voltage clamp their set of neurons for 30 seconds, starting at a moment that will be precisely coordinated across labs.
So we use a
Ready?
lot of
Go! Do you
we're
still see yourself waving in the mirror?
maybe not. I don't believe that. This is horrible. I don't believe in our equipment. I don't think the setups will be comparable enough to give me the same experience again. Okay, but now it's the equipment that fails, I think.
No, but before we blocked all neurotransmitters, we moved the neurons apart a little bit, but they're still doing the exact same thing.
Yeah, in theory, I should still see myself because I don't think. I mean, the neural activity is what makes me see things, right? The rest only influences the neural activity.
Mm-hmm.
I still believe in the neural activity. I'm starting to feel very stupid. I think this is impossible also, but like in theory, if you do it correctly, perfectly, because it's a theoretical thing, right? So I can assume that the machines are perfect
Mm-hmm.
that we're using. Okay, then
Mm-hmm.
I think you can make someone experience the waving. No,
I
I'm
mean,
not happy.
the way I think about it is if you hook up your brain to the output to its motors, you're still sending those electrical signals to move your arm muscles. You're still waving. So I guess.
Yeah, do you think you're physically? This I didn't even think about. You should be physically even waving.
Yeah, yeah. But and you receive inputs from your spinal cord. You're still receiving all those inputs, or like your neurons are still firing as if they're receiving all those inputs because they're firing
Yeah.
the exact same way.
Yeah. Yeah, yeah. So at some point you're not receiving the inputs anymore, but it doesn't matter if you voltage clamp everything.
Yeah, like all the input neurons still do the exact same thing as if it was connected to a body.
Yeah.
All your output neurons would still be doing the exact same thing as if they were connected to a body.
Yeah, this is in the last case when you shipped neurons away.
Hmm. Are you still happy with all of your answers?
Well, I'm not happy at all. But
Okay, that's yeah, I understand.
I don't know. But I'm thinking that there must be some change in your experience, but not in the waving, not in the basic action that you undertook and the basic thoughts that you had. Like maybe you have slightly different thoughts or emotions about the waving that you're doing.
Hmm.
Because like a lot of slower things will still be going on and are not all blocked,
That's actually
like
that's one of
for
my main
modulators.
arguments against this. Well, we can just tear the brain apart. Is what happens after those 30 seconds, right? Because if they're connected and they fire their action potentials, a lot of machinery is happening. The cells themselves are changing as they fire those action potentials. But they're also changing because they receive neurotransmitters, because
Yeah,
there's ATPase, there's blood, there's everything is happening. And if you take them apart, that is no longer happening. So in the intact brain, if you voltage clamp them after the 30 seconds, it's fine. But if even in the intact brain, once you block the synapses after the 30 seconds, your post-event brain will be different in those two conditions.
yeah, yeah. You cannot wait, and like if you wait with the replaying, something will have changed for sure.
Mm-hmm. Like even if you ship those neurons apart, even if you could keep them alive,
Yeah,
but it depends very much on how well you could theoretically control external conditions.
yeah.
There is, by the way, a very nice preprint on OSF preprints by Albert Giddon, Jan Aru, and Matthew Larkham. I've just linked it. Do action potentials cause consciousness?
Yeah,
Um,
but here they're also talking about action potentials because at some point I thought it was when you don't have the synaptic connections in the whole brain anymore. I think it's important what happens, like all activity that happens that is not translated into action potentials, right? The sub-threshold
mhm.
activity.
Yeah, yeah, yeah.
This.
I mean, we're also ignoring glia. I'm saying this for my glia friends. I've got you, fam.
Oh yeah, we are ignoring glia too. Yes.
I mean, there's a whole bunch of machinery. Like electrical activity is only a fraction of what makes up a mind, I
Yeah.
think. Um, Having said that, it is kind of the in and output.
Yes.
Like you don't control your muscles with chemical.
Yeah, and the question is very simple. Do you see yourself waving? It's not, do you still feel happy if you felt happy about the waving the first time?
Mm-hmm. Right.
Right. So, I mean, that could totally change, I think.
I mean, but arguably on that point, I mean, we know that deep brain stimulation can be used to treat depression.
Yeah,
So you
which is
can be
also,
sad, and then if you change the electrical activity without changing any chemical in your brain, you can become happy.
yeah, but this is a very general change of electrical activity, so it also
Yeah.
changes the chemicals.
I mean, indirectly, yes, but if you control just the electrical activity, you can make someone happy.
Yeah. Yes. But you are not blocking all the other, no, because in this experiment they're blocking all the synaptic communication and all kinds of other things, and then we're shipping the neurons apart and everything. I think that will influence a lot.
But you know, you could argue that, okay, say you have a serotonin reuptake inhibitor. What is the effect of that serotonin? How do you measure that? What is the conscious experience of that serotonin? Is that, I don't know, whatever it is? Or is that because it induces a change in electrical activity in the postsynaptic neurons that receive that
Oh,
neurotransmitter?
that we don't know.
I think that sums it up, yes. I wouldn't know. I don't have an answer. It's an interesting thing to think about, though.
Yeah.
So, yeah, getting back to that preprint, do action potentials cause consciousness?
It's a good question.
It's a good question. It's a great question. Yeah, one for the philosophers, perhaps.
Yeah. Or like it would be good to design an experiment because we have a lot of means to control neurons and electrical activity, and so we can do.
Not anything on a scale of a brain.
No. Okay.
This kind of ties in with that first topic, the Neuralink. We've heard a few billionaires, they're all, they're becoming older and they're starting to think about mortality and they're starting to think, but what if I could upload my brain into a computer? Um, and it's kind of the same problem. Like, even if you could magically record the exact electrical activity of every neuron in your brain, map every synapse, you would still not be able to replicate that brain in a computer. I don't think so, because you also need to do all the glia. You need to do the blood. You need to do nutrients. I mean, there's a gut-brain axis that you need to take into account. You need to control for all your neuromodulators, your RNAs, your transcription factors, all that other stuff that's machinery in your cells that is changing the cells as they are firing.
Yeah.
Your neurons aren't static firing boxes. They
all
change.
the stuff is influenced by what you eat, how your hormones fluctuate during the day, during the month, what your experiences are, whatever.
There was a very cool paper. Where is it? Let me try to find it. Sorry, let's move on. But I'll look up that paper.
Okay.